Okay, just ran out of time there on video 1. Let's move through. So this is video 2 now. So if we put our answer in our table, our 2 ends up in our units column. Okay, so as we can see, when we divide something by 10, what's happened is our individual digits have moved across into the next column. Okay, so when we're dividing, they move to the right. If we're multiplying, they move to the left. Okay, so let's go back to our 172. We can divide it by 100. So if we divide it by 10, that would move everything once. If we divide it by 10 again, that would move everything another place over. And dividing by 10 twice is the same as dividing by 100. Okay, so let's move everything 2 places over to the right. So here we go. So the 1, well, if I move it into the tens, that's divided by 10. And if I move it into the units, that's divided by 100. So we place our 1 there. Let's take our 7, divide it by 10, moves it into the units, divide it by 10 again, and it moves it into that tenths column. Okay, and then finally the 2, we're going to divide it by 10, goes into the tenths, and divide it by 10 again, and it goes into our hundredths. Okay, so here we're divided by 100, there were 2 zeros, which means divide by 10 twice, and we can move it over twice, so we end up with the answer of 1.72. Okay, question 5, find 1,000 less than 7,569. Well, what does less than mean? I want 1,000 less than a number. Well, in maths, less than or take away from, we might say. So we might say take 1,000 away from 7,569. And then as soon as we've got that language in place, we can then move across to how we might expect to see it mathematically. So 7,569 less 1,000, so take away 1,000. Now we could have it as a column. And let's go through it. So 9 lose 0, 9 take away 0 is still 9, 6 take away 0 is still 6, 5 take away 0 is still 5, and 7 take away 1 is 6. Okay, so we end up with 6,569. So in general, if you take away 1,000, so everything else is a 0 here in the columns from a number that's already in the thousands, you just need to take 1 away from the thousands column, and that moves the whole number down by 1,000. So for question 6, what are the first 5 multiples of 9? So multiples just mean numbers in the times table. Okay, so you might see this on a number grid, for instance. You just want the first 5. So the first one, 1 times 9 is 9. 2 times 9, or 9 add 9 if you like, gets us up to 18. If I add another 9, or call it 3 times 9, that's 27. Add another 9, or 4 times 9, that's 36. And add another 9, or 9 times 5, and that's 45. A really nice little pattern, which I'm sure your primary teachers pointed out to you. In the 9 times table, we can see that the digit in the units goes down 1 each time, so 9, 8, 7, 6, 5, and the digit in the tens goes up, so it's 0 there if you like, and then 1, 2, 3, 4. So the next number would be 54, and then 63, and so on. Okay. Complete the equivalent fraction. 1/3, or if you like, 1 out of 3 equals something out of 15. Now, this question was actually in the intermediates, so if you're doing well and you got this one right, you might want to try the intermediate set of questions as well. So the best way to think about this is to say, right, well, where do I normally see this? My teacher may have written it for me on the front of a test and said, you got 1 out of 3. Not many tests are out of 3, but you might have got 1 out of 3. Okay. And then your teacher comes along and says, look, I'm going to give you a similar test, similar difficulty, but this time it's going to be out of 15. Okay, so more marks available. And this is a proportion-based question. So you would say, well, okay, so my test is now out of 15, it was out of 3. So let's make some comparisons. So my test actually is now 5 times bigger. There are 5 times more marks available than there were in the original test. Okay, so if I was going to perform in a similar way, I would expect to do 5 times as well, or sorry, get 5 times as many marks, I should say, as I did in the original. So I'll multiply my score by 5 as well, and I'll get 5 out of 15. Okay, so an equivalent fraction is actually just a proportion question. It represents the same thing, just with a different, what we call denominator. Okay, so to find an equivalent, we could do it the other way around as well. Sometimes you might see the words simplify a fraction. And that simply means, where did that fraction originally come from? So I could work it the other way. I could say, well, I could divide 5 by 5 and divide 15 by 5. And that simplifies my fraction. So a test that's 5 out of 15 could be the same as a test that's 1 out of 3. Okay, and you'll notice whichever way I go, whether I'm making the numerator or the denominator, so the number at the top and the number at the bottom, bigger or smaller, it's in the same proportion each time. So I multiply or divide by the same number. Okay, so is this angle acute or obtuse? So let's have a reference point. So we would start with what we'd have as a right angle, which is 90 degrees. Okay, so we look at protractor. If you look at two lines that make this shape here, you might be familiar with the word perpendicular. Then they create a 90-degree angle. So acute means less than 90 degrees. So if we popped in, I'll do it at a slight angle there, because that's at a slight angle, our 90-degree angle there, we can see that this angle made by these two lines joined together is less than 90 degrees. So it is in fact acute. Question 9 was a bit weird. Write something in Roman numerals. It's just something that you might have come across. So again, a Google search will tell you that x represents, or cross really rather than x, represents 10 in Roman numerals. Okay, so we could have done a little Google. Let's do a Google. Okay, so let's go for that back to my original one. So 10 in Roman numerals is a cross. Okay, and then 30 is just 3 lots of that, so 3 crosses together, which is 30 in Roman numerals. Okay, and then finally, what's 9 times 9? Actually, that's quite a good question, is it? Because we did our multiples of 9 up here, didn't we? We did our first 5, so, and we kept going, in fact. So we had 6 here, and this is 7 times 9. So let's do 8 times 9 with our same pattern. So 8 times 9 would be 72. That number got bigger, that number got smaller. And then finally, 9 times 9. So 7 goes up to an 8, and the 2 goes down to a 1, and we end up with 81. Okay, so hopefully, it doesn't matter if you got them all right at all. Hopefully you found some of the explanations useful, okay? And these videos are really just to help you along. If you just get better at the things that you already know how to do, that's brilliant. If it's just practice. If there are still some things you've just got no idea about after this video as well, just make a little note, and you can bring that to your teacher on your first day, and they can have a little look at that for you. So just look at this as a revision a little bit more. Don't get too worried if you can't do them all. It's not a problem at all. Okay, so the important thing is you took part. Okay, so there'll be 5 more of these videos throughout the summer holiday. I hope you enjoy them, and I'm really looking forward to seeing you in September. Have a lovely week, and see you next Monday.